All right, so thumbs up here. Let me see what we're coming up with. So if you're getting your answer like this, or it's like x sub 1, x sub 2, I haven't actually shown you how to give your answer this way. So this tells me you're getting it from some sort of site or app that's solving it. And you know, those kind of apps and sites have a purpose. They're good for checking your work, but they're not great for teaching you how to do the problem, because you're not showing me any of the steps here. You can't use like an app or a site like this when you take a test. You actually have to know how to go about the steps and solve it. Okay, so identifying those like terms, good place to start. But it looks like we're kind of lost. So these two terms are both just constants. They're just numbers. There's no variable part. And so we can get them together. The term with the variable is on the left. So we're going to move the constants to the right using the inverse operation of subtraction, which is addition. So what you want to do is just add 1 2/10 to both sides. And the reason we're choosing to add 1 2/10 to both sides is because when you add opposites, -1 2/10 and +1 2/10, these actually add to 0. So they just cancel each other out. And they go away. And what I'm left with is the equation. We have 1/10 x, and I did figure out how to add an exponent finally on my laptop. It only took me forever, but figured out a way. And if I add the right-hand side, don't be afraid of adding decimals. It actually turns out to be just an integer answer. 8 8/10 plus 1 2/10. You line up your decimals, you add the tenths place together, carry the 1, and then add the ones together. What does that add to? 8 8/10 plus 1 2/10. Anybody in here now? Yeah? 10. Yeah, you're right. So we wrote of some of our decimals already. All right, so those just add to 10. Now what you have is an equation where on the left-hand side you have your variable term, a squared variable term, and a coefficient of 1/10. And on the right-hand side you have a constant of 10. So we're not going to take the square root of both sides yet. What we want to do next is get rid of this coefficient. So 1/10 and x squared are being multiplied together. So I'm going to use the inverse operation of multiplication. Just division. We're going to divide both sides by whatever number gives me 1. And that would be dividing something by itself. So if I divide both sides by 1/10, 1/10 divided by 1/10, this is 1. They cancel each other out. Now I got to figure out what is 10 divided by 1/10. Our decimal is going to disappear again. See if anyone has it looking at the problem. so far. You can open up the calculator app or Chrome browser calculator and divide 10 by 1/10. This person figured it out. That's 100. So all our decimals disappeared. Makes it a little easier to do some calculations now. Up until this point, this is stuff that you've learned previously when solving equations. But the new thing we learned about is when you have a variable squared, how do you solve for that variable? So we learned yesterday that there are 2 square roots, a very positive number. 100 has 2 square roots. 100 is a perfect square because it comes from squaring integers. And so if I take the square root of both sides, I have to rewrite this equation as x equals. This is where that positive, negative square root come in of 100. So that's just our definition of taking the square root. We have to consider both the positive and the negative square root of 100. We don't know if x, which one it could be. And so square root of 100, that's where these 10 and negative 10s were coming from. Okay. You take the square root of 100, you get 10. And so we have plus minus 10. So those are our 2 answers. X equals 10 and x equals negative 10. And you could always check that. You could plug it back into the original equation, and it would make a true equation with both those values. You guys have any questions on that warm-up problem? Make sure you keep your mask over your nose, okay? Please. Before we go forward, I want to go back and look at the problem we were working on yesterday, which was right here. And so I got 4 of you to try it to solve 3x squared plus 6 equals 33. And see this person here, they subtracted 6 from both sides. That gave us 3x squared equals 27. Divide both sides by 3. So x squared, a little bit lost on what happened here, but up until a certain point, that looks really good. Make this person a little bit easier to see here. So 3x squared equals 33 minus 6, which is 27. Divide both sides by 3. When you take the square root of both sides, you get x is equal to plus minus positive and negative 3. Okay, the square root of 9 is 3. And so these are the 2 answers. X is either negative 3 or positive 3. And if you plug it in, you would get a true equation with both of these values of x. Okay. So a couple of you showed your work on that. 3 of you got it right. You can still go back to that slide and do it later. But we're going to keep working with equations today that we can solve by taking the square root. And so they look a little bit different now. So this example here, we have x plus 5 in parentheses, and that entire binomial is being squared. And on the right-hand side, that's equal to 36. So I want to get x by itself. All the time when you're solving an equation, you're trying to isolate your variable. But right now, there's a couple things happening to x. X is having 5 added to it. It's also in parentheses being squared. And so to get rid of these two things that are happening, I have to get rid of the squaring before I can get rid of this addition. Because this is in parentheses. I can't just go in here and undo this until I deal with this exponent of 2. So we're going to take the square root of both sides. You take the square root of something that's squared, that has this variable there, we need to add in this positive negative symbol. And we're taking the square root of both sides. So square root of 36 is actually just 6, because 6 times 6 is 36. And then x plus 5 equals positive and negative 6. Well, now we can get rid of this plus 5 by subtracting it from both sides. And that leaves us with x is equal to positive negative 6 minus 5. And we're going to break this into the two possibilities. So if 6 is positive and if 6 is negative, that's what we're doing here. Either we're going to get x equals negative 6 minus 5, which is negative 11, or we're going to get x equals 6 minus 5, which is 1. So our two solutions to this equation are x equals negative 11 and x equals 1. So the difference here, in the parentheses, something is being added to x, whereas yesterday we didn't have anything that was being added to x that was being squared. Okay, it was just x squared. But here we have x plus 5, and that whole thing is squared. It's a binomial squared. And this is how we're going to tackle these. Now, it could be that we have something like this on this example slide here. The problem's written twice, but 3 times x minus 5 squared equals 18. So there's all kinds of things happening to the left-hand side of that equation. We have multiplication by 3, subtraction of 5, and there's squaring of a binomial going on. You have to undo these things in a certain order. So what we want to do is get rid of the factor of 3 first. We're going to divide both sides by 3 as our first step. Divide both sides by 3. And so they're not really showing you a bunch of doing the same thing to both sides, but if I divide 18 by 3, how much do I get? Yep, 9. You're right. So I'm going to put, no, not 9. Sorry, just kidding. Close to 9. Take 9 and flip it upside down. 6. Yeah, 6. So we're going to get the 6 right there. Okay, so I got rid of that factor of 3 first. And now this kind of looks like the last example we saw. Before I can get rid of the minus 5, I need to get rid of the squaring of 2. So we're going to undo the squaring by taking the square root of both sides. And when we do that, we're adding in that plus minus sign, and a 6 is still under here. So this becomes x minus 5 equals positive negative square root of 6. Now I can deal with the addition and subtraction of something to x. And so to get rid of that minus 5, we do the inverse operation of subtraction, which is addition. We're going to add 5 to both sides. Okay, adding 5 to left side makes negative 5 plus 5 turn into 0, cancels out. We still have positive negative square root of 6. And then we want to solve for both possibilities. So x either equals positive square root of 6 plus 5, or x equals negative square root of 6 plus 5. Notice as we're moving through here, we went from, on the current line we're on right now, we have this equal signs, but then it switches to the wavy equal signs. Those are indicators that we are rounding our answer. The square root of 6 is an irrational value. 6 is not a perfect square, so I'm not going to get integer answer. It's going to be a crazy decimal that I'm going to need to round. And so I'm going to go ahead and just use the Chrome calculator and show you how it works for this one. Use whatever calculator you want, but you will use a calculator to evaluate your square root. X is about the square root of 6 plus 5. So I want to do the square root of 6, and I'm going to click on the square root symbol and then put a 6. If I put plus 5 right now, it'll be incorrect. I have to close the parentheses because that plus 5 is not under the square root of 6. It's not a part of that square root. If it was, I'd be taking the square root of 11, and I don't want to do that. I want to take the square root of 6 and then add 5 to it. So by closing the parenthesis, I'm limiting what the square root is being taken of. Now I could put in plus 5, okay, and this is now separate. It's not under the square root symbol. So when you hit equals, we get something that looks like this. And if we round this answer to nearest hundredth, 7 and 45 hundredths. So x is about 7 and 45 hundredths. Or x is about something else. So clear out your calculator. Now we want to figure out what is negative square root of 6 plus 5. So if I press subtraction sign, that'll give me the negative I need. Then the square root symbol. And then a 6. And that's all that's under the square root symbol is just 6. So we need to close the parentheses. And then we're going to add 5 after. Okay? So this is what we need to type in. And that's going to give us our answer. Negative square root of 6, close the parentheses, and then add 5. This turns out to be about 2 and 55 hundredths. So the approximate solutions are x is approximately 7 and 45 hundredths, and x is approximately 2 and 55 hundredths. Now, when you're checking your work, anytime you take your answer and you plug it back in, you should get back to what you started with. But if you rounded like we did here, you're going to get really close to your answer, but you probably won't get it exactly. So let me just show you what I mean. If I check this last answer here, 2.55, right? That's why I said x is about. And if I subtract 5 from that amount, and then I square that, and then I multiply that by 3, where did the negative come from? What did I do? Let me try that again. Oh, I know why. I need to put parentheses around that. So I want that whole thing to be raised to the I have to do it separately. Square that amount and then multiply that by 3. So now I'm back to something that's really close to 18, but it's not exactly 18, and that's expected because we rounded. Okay, so that's That's part of the reason why when you do need to round, you should limit it to the very end of your problem after you've done all your calculations. Yeah, you want to minimize rounding if you can. Do you guys have questions? What we just did, we're going to do another one, and then you're going to do one. Ask questions through Go Guardian. You can just ask in the class. You can ask through the Meet. Anyways, fine. Whatever you're comfortable with. All right. So look at this side here. This other problem we're going to do now. We have 4 times the quantity of x plus 10. That's all squared, and that equals 24. I'm trying to solve this equation. My variable is x. I'm trying to get it isolated, trying to get it all by itself. There's lots of things happening to it. 10 is being added to it. That whole binomial is being squared, and we're multiplying by 4. And so we want to kind of like unwrap the variable, starting with the most outermost thing, which is this 4 here. So I'm going to divide by 4 first. On both sides. So that's what you guys should be doing first on your slide. Divide both sides by 4, and then write your new equation. This looks really good right here. So if I divide both sides by 4, the 4 divided by 4 is just 1, so we're just left with the x plus 10 squared. And on this side, 24 divided by 4, that's just 6. What are we going to do next? Do we subtract 10 from both sides next, or do we take the square root of both sides next? What should we do next? If you're not sure, look at what we did on the example to the left. What did we do after we divided this factor out from both sides? Divide both sides by 3, and then the next line here says take the square root of both sides. We're going to take the square root of both sides of this equation. When you take the square root of a variable, that's when this plus minus is going to show up. Because my variable is being squared, I have to consider if it's a positive or if it's a negative. And that's why that shows up right here. So after we take the square root of both sides, on the last problem, we added 5 to both sides. We're not going to add 5 over here, but we do want to get rid of this 10. X plus 10, what can I do to get rid of plus 10? Yep, subtract 10. You're right, Arabella. Ten minus 10 is 0. Those go away. And so we are left with x equals so you want to make sure that you're subtracting 10 is not under the square root symbol. Okay, it's separate from that. We can't just throw it in there. But now we have x isolated on the left, and so we can break this into two equations. This is where you're going to use a calculator. So we have the negative square root of 6 minus 10 minus square root 6, close parentheses, then minus 10. That's how you want to enter this first one. And we'll be rounding because the square root of 6 is not going to be a rational number. That's irrational. One of your answers is negative 12 and 45 hundredths. Your other possibility for x, now it's the positive square root of 6. Close your parentheses, subtract 10, negative 7 and 55 hundredths.